Wallis theorem. When we say Wallis theorem, its integration is a definite integral of trig function of power from 0 to pi over 2. So you can only apply the knowledge of Wallis theorem when your boundary is from 0 to pi over 2. Are you with me? So Wallis theorem says that when you have your boundary to be 0 over pi over 2 and you have a trig function raised to power nx, by definition Wallis theorem said is equal to n minus 1 into n minus 2 into 3 n minus 5 dot 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 over n into n minus 2 n minus 4 dot dot dot. That's the definition of Wallis theorem. Now said when n is equal to even number, you add pi over 2 at the back. But when n is odd, you don't have to put this. Are you with me? So that's the definition of Wallis theorem. But what is the meaning of this? Let's use examples to explain it better. Look at this question. Evaluate integral 0 to pi over 2 sine raised to power 8x. By Wallis theorem, it says 8 is n. Then we have n minus 1, which is 7, times n minus 3, which is 5, times n minus 5, which is 3, times n minus 7, which is 1. Note, in Wallis theorem, you must not get 0 or negative number. So you stop at 1 because after 1, the next number will be what? Negative. Over n is 8. 8 minus 2, 6. 8 minus 4, 4. The next number, 8 minus 6, 2. 8 minus 8 is 0, but Wallis said you must not have 0. So this is the simplification to this. And the power n is even, so you add pi over 2, which is the same thing as 35 pi over 256. Final answer. So what Wallis is just trying to tell us that instead of applying reduction formula to this and using your definite integral to simplify to have your final answer, you can apply his method by just applying this definition to get your final answer. But if you don't want to use Wallis theorem, what you just have to do is you first apply a reduction formula to this. After evaluating your reduction formula, then you put your definite integral, your upper boundary in place of x minus your lower boundary in place of x. So Wallis theorem tried to save us from distress by giving us a definition that is applicable to it. So this for a function. But what if the question is now integral 0 to pi over 2 cos raised to power 5x? Still the same definition. Then the simplification will be 4 times 2 over 5 dot 3 dot 1. 5 is odd, so we don't need to put pi over 2, which is 8 over 15. Final answer. Similarly, Wallis theorem moved down to two functions. What if you are asked to integrate 0 to pi over 2 sine raised to power mx cos raised to power nx? So since we've been able to deduce a reduction formula for this, what you just have to do is apply reduction formula and put your boundary. But still, Wallis theorem tried to save us from distress by giving us the definition. What it said is, by definition, is the same thing as m minus 1, m minus 3, m minus 5 dot 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 times n minus 1, n minus 3, n minus 5 dot 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 over m plus n minus 1 m plus n minus m plus n minus 2, m plus n minus 4, m plus n minus 6 dot dot dot. So that's the definition it deduced for us. But it said if both m and n are odd, you don't need to put pi over 2. If one of them are odd, you don't need pi over 2. You can only apply pi over 2 if both are even. Now let's try to solve questions on this kind of function with Wallis theorem. From the lectural material, question number 1 says that integral 0 to pi over 2 sine 3x cos 5x dx. From Wallis theorem, I can say is equal to 3 minus 1, which is 2. 3 minus 3 is 0, but Wallis said you must not have 0 or negative number. So I'll stop here, move down to the next one. N minus 1, that's 4. N minus 3, that's 2. N minus 5, that would be 0. So just because I must not have 0 or negativity, I'll stop there. Over m plus n. M plus n is 8. Then m plus n minus 2, 6. M plus n minus 4, 4. M plus x minus 2, minus 6, 2. M plus n minus the next number 8. I'll have 0. So just because I don't want to have 0 or negative answer, I stop here. So from here, then I have it to be 2 year, 2 year, 4 year, 4 year, 2 year 1, 2 year 3 is equal to 1 over 24. Final answer. So Wallis theorem is very easy. It reduces us from the stress of applying reduction formula to a question. But you can only apply Wallis theorem when your boundary is 0 to pi over 2. But in case you are not given a question, you are given a question that is not 0 to pi over 2, and you are asked to apply Wallis theorem, what you just have to do is you have to apply change of limits. Try to convert your question from the boundary you're given to is 0 to pi over 2. Then after that you can apply Wallis theorem. But you can't apply Wallis theorem when your boundary is not from 0 to pi over 2. So Wallis theorem is applicable when the boundary is 0 to pi over 2. Let's solve one more question. It says integral 0 to pi over 2 sine raised power 6x cos raised power 4x. So to solve this with respect to x dx is the same thing as m minus 1, 5, m minus 3, that will be 3, m minus 5, 1, m minus 7, that's negative number, so you stop here, times n minus 1, 3, n minus 3, 1, n minus, you have negative number, so you stop there, over m plus n, 10, m plus 10 minus 2, 8, m plus n minus 4, you have 6, minus 6, you have 4, minus 8, you have 2, minus 10, you have 0, so you stop here. But because this and this are even, so you apply pi over 2, which is the same thing as 5 year 1, 5 year 2, 3 year 1, 3 year 2. Then I have it to be, if you multiply everything together, you have 3 pi over 5, 1, 2. Final answer. But what if the question is integral 0 to pi sine 9x cos raised power 4x dx? To integrate this is 0 to pi. I can take it to pi over 2 by saying it's the same thing as 2 integral 0 to pi over 2 sine 9x cos 4x dx, which is the same thing as 2 times Wallis theorem. I have if I apply Wallis theorem to that, I have 8 times 6 times 4 times 2 times 3 times 1 over 13 times 11 times 9 times 7 times 5 times 3 times 1. This eliminate this eliminate this, then I have it to be equals to 256 over 15015. Final answer when you multiply it through. So that's all on Wallis theorem. And but don't forget to apply Wallis theorem. Your boundary must be 0 to pi over 2. But once your boundary is not 0 to pi over 2, you have to, and you are asked to use Wallis theorem, then you have to find all means applying change of limit to convert your boundary to pi over 2. Thank you very much.